So guys, now in this section of the course we will going to discuss network address translation. We will going to discuss the three aspects of this topic, that is what actually network address translation is, why do we need it, what problem does it solve, and how networking devices implement the concept of network address translation. So we will going to discuss this topic in pretty much detail. So to start with, network address translation is a technique which primarily aims towards conserving public IP addresses. And the second reason is hiding the private network from the internet. Now we already know that IPv4 addresses are actually 32-bit addresses. Alright? And therefore the maximum number of total IPv4 addresses that is possible is 2 raised to the power 32 minus 1. Alright? So IPv4 addresses are pretty much limited. They are not available in a very huge quantity, and therefore we need to find some way to conserve the usage of these IP addresses. Because you can see in the last 10 to 15 years, the number of equipments which are connected to the internet has really exploded, and they are increasing exponentially. And every equipment that is connected to the internet potentially needs an IP address. So if you are as an individual who owns let's say phone which is connected to the internet, you also have a laptop which is connected to the internet, you also has a television set which is connected to the internet. So as an individual you are already consuming 3 public IP addresses if network address translation is not invented, let's say. So this is regarding one individual, and therefore because the number of IPv4 addresses are pretty much limited, therefore network address translation has been invented with a technique to conserve the usage of IP addresses. The second reason is hiding private network from the internet. So this we will going to discuss along the way. Now, network address translation is configured on the boundary devices, and the device on which NAT is usually configured is a firewall or a gateway router. So you can see in this diagram, let's say the network which is inside this yellow box is a private network of some organization. Let's say it could be Microsoft Corporation, it could be Google, or let's say it could be NASA, or let's say it could be any college campus. Some private network which is owned by some organization. Alright? All the computers A, B, C in this private network belongs to that organization, and they store sensitive data that belongs to that organization. And only the users or the members of that organization are allowed to use these machines. Alright? So this is just a private network. Now, there is a device which we call it as firewall or gateway router. This firewall or gateway router is installed at the boundary of the private network and the outside public network. Alright? So all the traffic that leaves this private network and goes to the public network or internet, and all the traffic that comes from the internet into the private network has to go through this firewall device. That's the responsibility of this firewall device, to inspect or examine all the network traffic that is going from inside to outside or coming from outside to inside of this private network. Alright? And therefore this firewall device has 2 types of interfaces. The first interface is called inside interface, the interface which is connected to the private network, and the outside interface is an interface which is connected to the public network. Alright? Now note that this private network, though in this diagram you see a very simple representation which has one L2 switch and connects the 3 machines ABC, but this private network could be very large and complicated network. It may contain thousands of end host machines, hundreds of L2 switches, and hundreds of L3 routers. There is no restriction on that. Alright. So by default, all the traffic is allowed to pass through the firewall from the inside to the outside. So all the traffic can go by default. By default means by the default configuration that exists on the firewall device. So by default, all the traffic that is generated by the host machines or network equipments which is present inside the private network is allowed by the firewall to go from the inside interface to the outside interface. But the opposite of that is not allowed. All the traffic is blocked by default, which passes through this firewall from the outside network to the inside network, and this is blocked by default. So until or unless as an administrator you do certain configuration on this firewall device to allow the traffic from the outside public network to enter into the private network through a firewall, by default all the traffic is blocked otherwise. Alright. So network address translation is a configuration which is installed on this firewall device. Note that outside public network, when I say outside public network, it means an open internet. And we already know that open internet is pretty much an unsafe area. All type of intruders, hackers, malicious softwares are present on this outside public network, and therefore it is desirable that a private organization which is maintaining its private network, which could be very large or complicated, to protect its private network from all the types of thieves who are sitting on the public network and they are ready to attack and steal the sensitive data of the private network which is owned by the private organization. Alright. So for that, the specialized devices called firewalls have been implemented, and network address translation is one of the tools which are implemented on these firewall devices, which helps achieve these two primary objectives, that is conserving an public IP addresses and hiding the private network from the internet. Right? So to understand network address translation, we will use Cisco ASA firewall. If it is for the first time that you are getting introduced to this ASA firewall, it's a networking device which is manufactured by the Cisco. Alright, and we will going to use the Cisco ASA firewall device to understand that how network address translation is implemented and work. Alright. NAT rules are applied on the ingress and egress interface of a firewall device. So here you applied the network address translation rules. We will going to see how it is done in our lab. So you are advisable to set up GNS3 or EVNG lab, and the image that we will going to use in order to implement network address translation is Cisco ASA firewall. Alright. So it is your responsibility to set up a lab, that is install GNS3 on your local machine if you do not have already, and be ready with the Cisco ASA firewall image. Alright, in the next lecture video, we will going to discuss that what topology we need to build in order to implement network address translation lab. We will going to discuss different real world scenarios where network address translation actually help us to achieve network security or preserve the IPv4 addresses. And also, though I am saying NAT, network address translation, there is something called PAT, which is called port address translation. Alright, and NAT and PAT has to be studied together. So in this section of the course, we will going to discuss NAT followed by PAT. You can say that PAT is nothing but it is an extension of NAT. Alright.